In these examples, we're going to be trying to find the area under the curves from 0 to 2 pi of a trig 1, and then we're going to find the area under a curve um, of a rational that has these fractional exponents, and we'll see how this complicates some stuff. So first one is we're going to do the antiderivative of this. I would like to take that 3 out because I feel like the 3 should play a role in doing my antiderivative, and it really doesn't. So I'm really looking at from 0 to 2 pi. We're going to take the 3 out, and then we're going to go from 0 to 2 pi of sine x dx. All right, so we're going to do the antiderivative of this. So the 3 is just kind of floating out there. For sine, I want to undo the sine, so I don't remember where I'm at on the pattern. So I know that a sine goes to a cosine, derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, derivative of negative cosine is sine. So we're actually here wanting to undo. Okay, so the antiderivative of sine is going to be a negative cosine. So that 3 is going to be multiplied by negative cosine x, and we're going to go from 0 to 2 pi. So if I kind of rewrite this, I'm looking at a negative 3 cosine x from 0 to 2 pi. All right, so if I plug this stuff in, I can actually leave that 3 out and do cosine of 2 pi minus cosine of 0. I can do that. I had another situation up here where I had 2 times this fraction. I ended up applying the 2 on both of them, but I could have very much just left that 2 out and did this piece minus this piece and then figured out my answer and then multiplied it by 2, because the 2 really distributes in. And so it depends on what your comfort level is. This would basically be a negative 3 cosine 2 pi minus a negative 3 cosine 0, or do this and then just multiply by negative 3. Either way is going to work. So if I do cosine of 2 pi, here's where I think of the graph. Here's this. Here's cosine. Here's 2 pi. I get a value of 1. So it's a negative 3. Cosine 2 pi is 1 minus cosine of 0 is also 1. So 1 minus 1 is 0. So negative 3 times 0 gives me an area of 0. So that is not crazy uncommon. If you're graphing a sine curve, if you think about what the sine curve looks like, and even the 3 is going to vertically stretch it, which is just going to make it taller. But you're finding the area of this, and you end up subtracting the area of this because it's a negative area. And so they end up countering each other if you perfectly do one cycle, which is exactly what we're doing. We're doing perfectly one cycle. So it's not crazy that you end up getting on some of the trig ones because of this kind of pattern over and over and over again that they end up canceling each other. So just depends where you're going. So we do the next one. We're looking at, I need to rewrite this one, maybe a couple little steps to it. So first thing that I'm going to do is, there's not much I can do with this. I am going from small to big. A 16th is smaller than a 4th. So that I don't have to mess with. So I'm looking at a 16th, I'm looking at a 4th. And then here, though, I'm going to rewrite these. So this is a t to the 1/2. But I'm also going to break up this fraction and have t to the 1/2 over t minus 1 over t. All right. And then I'm going to simplify this a little bit because I can just take this power. I can take 1/2 minus the 1. So I have a 1/16, a 1/4, and I have, this is going to become 1/2 minus 1. So that's t to the negative 1/2 minus, and I'm going to leave this one because this has a very natural log field to it. That if you remember, if you're looking at an original problem and you do the derivative of a natural log, you get 1 over x. And so that has that feel, and I'm going to end up going backwards on it. So I don't want to mess with it because I recognize it. And so I'm going to leave that as a 1 over t dt. All right, so this is what I'm taking the antiderivative of. So if I do this one, I'm going to add a power and then divide by that power. So when I do that and I add my power, I get a 1/2, but I don't want to divide by a 1/2. I can instead multiply by its reciprocal. And its reciprocal is 2, right? And then here, I'm doing the antiderivative of 1 over t, which is the natural log. So I have the natural log, and I will do an absolute value in here just in case. That's not nice. Because we can't do the absolute, we can't do the log of negatives. We don't have negatives, so we should be fine. And then we're going to go from 1/16 to 1/4 on our area. All right, so let's start to kind of do the math of this. So this I know that I have, it's a square root. We're going to do 2 times 1/4. That will be square rooting minus the natural log of 1/4. So we're going to find the area of that minus 2 times the 1/16 that will be square rooting minus the natural log of 1/16. Okay, so let's figure out what we got going on. So this one, we're going to be square rooting a 1/4. And so if you remember, we're square rooting a 1/4. We're really just square rooting the top and square rooting the bottom. So that's going to be 1/2. And then we're going to multiply that by 2. So 2 times 1/2. Right? And then minus, we're going to try to figure out what we can do with this. I can bring this 4 up, and that would make it a 4 to the -1. And the only reason I like that is because logs don't keep exponents, so I can pull that exponent actually in front. And then over here, let's see what we got. We're going to be square rooting the 1/16. So same thing where we'd be square rooting the 1, square rooting the 16. So that's a 4th times 2. And then minus, now this is actually, the 16 is something that has a 4 in it. And so that 1/16 I could write as 1 over 4 squared. And then I can bring it up and make it a negative exponent. All right, just because, hey, if I can make those match, then I'm going to have some like terms that I can put together here in the end. So next cleanup, we got 1/2 of 2 is a 1. We have exponents don't stay on logs. We can pull that exponent in front and make it into a positive. So that's plus the natural log of 4. And then this is, we're going to be subtracting 1/2. And we're going to be subtracting a negative. So that's going to become positive. However, I'm going to have a -2 coming in front as well. So I'm going to have a negative, and a negative. A -2 is going to come in front. And then it'll be the natural log of 4. Wonderful. So I have 1 minus 1/2, which is 1/2. I have a 1 natural log of 4 minus a 2 natural log of 4 is a -1 natural log of 4. And that is what I can simplify to. There might be one other little thing that I could technically rewrite 4 as a 2 squared, which would have another power. We could bring that in front. But I don't know if I see any value to being able to go any further with that. So if I can't really do it to make it simplify a little bit further, then I might as well just leave it. All right, so that was a couple examples, a little more challenging, some trig involved, and a fraction that I actually could break up into individual pieces and then do the antiderivatives of all those individual pieces.